Alrighty, so now that we've done all of our major and minor component calculations and we kind of know what we're looking for, what I've gone ahead and done is off camera I sourced all of my components. So I just did a little shopping around, and I actually also created them. I created a library with all of them. So if you look at all these components right here, um, these are the ones that I'm going to be using in the project. So I went and created a schematic library, and I went and created a PCB library. So all of these components have footprints. They have like their data sheets, all that stuff that I've mentioned in the component creation tutorial. I've went and done for all of these. Um, so then now what I'm going to do is I'm going to use the application circuit that is shown on the datasheet as a guide, and basically I'm just going to create that circuit with all of the components that I've you know uh, created in Altium. So that's the next step for me. Alrighty, this pretty much wraps up the schematic capture portion. I want to make a couple comments though before I end the video. So if you look at some of the component values, you'll notice I didn't use the ones that we calculated exactly, and that's just because I did some more. I looked through the data sheet more, look at some other reference designs. And for the design purposes, I thought it was just safer to go with these exact component values, because in the end of the day, it doesn't necessarily make much of a difference, like as far as the process goes. So I think we'll learn more about why different component values were chosen than the ones we arrived at whenever we start doing more designs and stuff like that. It's not really going to affect how you do your layout or anything else like that. It's just different values in your BOM will be slightly different. I just thought it was safer to go with the reference design values. Also, you'll notice this little red boxes I put around each side. So one thing about the flyback converter, I don't know if I've mentioned this yet, but so whenever you're designing the flyback converter, there's actually two different ground references that are used. Here you'll notice one is the high voltage and then others the low voltage. So one way to think of it is the high voltage side is the side it's connected to the wall. That's where your high voltage, that's like the return path for your high voltage line, right? So say you have like 170 volts DC coming here and it's returning through the line that is the high voltage ground. On the low voltage side, you're having only 5 volts return here. And the reason you want these separate is for the purposes of safety. So let's say something malfunctions and somehow something gets shorted to ground and basically your ground plane gets just pulled high or something like that. It's extremely dangerous. You can get electrocuted and a lot of bad things can happen. And you can also damage the device that's plugged in. So that's why you want to have separate ground. So basically what you'll have is a low voltage ground on one side and a high voltage ground on the other, and they're both separated by the transformer. So that's what these little red boxes represent right here. Oh, I forgot something tiny, but yeah, that's pretty much it. So this is basically what our schematic looks like when it's all said and done. So the next phase will be to go to the layout portion of the project.